Well, I don't know about that. We're gonna simplify radicals, and we're gonna start with prime numbers. So, do you know what a prime number is? Excellent. The factors are only one and itself. Okay, I have a list of prime numbers here. We're going to do stuff with those prime numbers, but okay, you guys, prime numbers have exactly two factors, one and the number itself. So some people wanted to think 6 was prime. 6 is 1 times 6, 2 times 3. The factors of 6 are 1, 2, 3, and 6. That has 4 factors. 5 doesn't divide into 6. So, is 1 a prime number? What are the factors of 1? 1 and 1. You have to have 2 factors. Exactly 2. So 1 is neither prime. Right. But 1 itself is not prime. So if you ever go on Jeopardy, you'll know that. Math question is pretty easy, actually. Okay. Here's the list of your prime numbers. Okay, so in your notes, you have prime numbers. Okay, Jane, put that away, please. And really, to do these problems, mostly you just have to know these first ones. You do have to recognize if a number is prime, and you have to recognize if you have a perfect square. What are perfect squares? Right, so 1 times 1 gives you 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Okay, you can square root these. The square root of 4 is the same as 2. Okay, Jack? Yeah, you should have your iPads up. You're using paper copies. Okay, so let's see how we simplify radicals. And I gotta go find my slide rule. The only reason why we simplify radicals in the old days is because we didn't have calculators, gents. And put that away, please. Your iPad. Yeah, I know, you're not listening to me. Anyway, the only reason we had slide rules, and that's how we did our calculations. It's kind of like an abacus, but it's not. But to give you that idea. You couldn't, yes, because you couldn't divide by a radical. That's a radical, that's square root of 18. So we couldn't divide by it, so we had to simplify them. Well, the reason you have to know how to simplify radicals now, guys, is because it's on the ACT. Do you really need it in real life? Never. Never. Because we have calculators. I'm just being honest, but I have to teach it because it's part of the curriculum and it's on the ACT. It is not in a Minnesota Standard, which is good. Ready? Okay. So this is the square root is a radical. And I want to simplify it. That square root of 18, it has a perfect square that divides into 18. I want it in simpler form. And so we're going to simplify this, and this is one way. You learned how to do this last year. A lot of you did. We're going to take 18 and divide by a prime number. I usually start with the smallest ones, like 2 and 3. So we're going to divide by 2. And how many times does 2 go into 18? 9. Well, 2 doesn't continue to work, so what's the next number that works? 3. Like, let's put little bars here. I think that might help. Yes. You can. Okay. If you... Okay, guys. If you divide 9 by 3, what do you get? You get 3. What goes into 3? 3. And when you're done, you end up with a 1. You're just dividing. You know what it is? It's a factor tree. Remember factor trees? You want to start with a prime number. 9 is not a prime number. 2, look on the sheet before. 2, 3, 5, 7. Those are the prime numbers. You're going to usually use the small ones. You remember factor trees? You would say, oh, that was 3 times 6, or 9 times 2, doesn't matter. Yeah. Well, that's really what we're doing. But this is an easier, guys, this is an easier way to do it. So what I do is, because this is really the square root of 2 times 3 times 3, or 2 times 9, that's the same as this, Nick. What's the square root of 9? 3. Now that is what comes out of the radical. So it's 3 times the square root of 2, and I put the square root behind it, so there's no confusion. That's what's happening. How do you do the problems? It's actually pretty easy. No, this, we divide it by 2, and this is what we got. We divided by 2, and we said 2 goes into 18 9 times, and then we found another prime, 3, and 3 goes into 9 3 times. And then we took 3 and divided 3 into 3, 1, it goes in 1 time. So this is what 18 factors give you with that factor tree. It's the easy way to do it. The ones that match go on the outside of the square root, and anything that's left over goes back inside. All multiplication. Do they have to be, could I do 3, 2, 3? Yes, doesn't matter. Let's try another one. I got a few examples here for you to get it. And I'm going to collect this, so you need to do it. How about 27? What's the prime number that goes into 27? 7 doesn't go in. Jake? 3. So 3 goes in how many times? 9. Prime number that goes into 9? 3. Prime number that goes, I have to divide that. 3 goes into 9, 3. And what goes into 3? 3 goes in 1 time. Okay, so it's the same thing. You can, but what happens is, when you do that, you do 27, and you go 9 times 3, you tend to do this. That's not right. Okay, James? That's not right. Because you have to bring that 3 down. What happens is you forget it. And the matches, they go on the outside of the radical. So I have matching right here. It doesn't matter which pair I take. But what didn't match? There's still a 3 left over. So it's still inside. Because this is the square root of 9 times the square root of 3. Square root of 9 is 3. Square root of 3 can't do anything. You can use either method, but this works really nice. Oh, what's 30? Oh, Matt, question? Yeah. The answer, I'll highlight, is this little. Okay, I'm using the crayon, that one. You should know the answer to the next one.
Yeah.
6. Can you see that? The crayon? Kind of. Those are the crayons. So it's 6. Okay. Okay, so some are going to be perfect squares on the worksheet. No, some are going to be perfect squares, like the last one. Okay, 60. Let's divide that. What goes into 60? Okay, 3. We want them to be prime numbers, because that gets you to the bottom of the Christmas. 3 goes into 60 how many times? 20. Ah, you were right. Now what goes into 20? 5. 6 is in prime. Remember that 2, 3, 5, 7. 2. So that gets 10. Now what goes into 10? 5? 5 goes into 10 how many times? 2. What goes into 2? 2. And you keep going till you get the 1 there. Now, which are the matches? The 2's match, right? So those come out, because you have 2, it's the square root of 4 really. It's 2 times the square root of what's left over? 3 times 5. Because what didn't come out? They're all under the radical. This is the ones that don't have a match stay there, and that ends up being 15. You can't simplify the square root of 15. It's not fine, but you can't simplify it. That's okay. Because what is this? This is the square root of 2 times 2 times 3 times 5. If you get a match, it gets to come out. I'm still left with the 5 and 3. Let's do another one. You can't. You can't do it. You can't. Because there's no matches. That's as simple as it gets. Now, does 2 times the square root of 15 mean anything more to you than the square root of 60? If anything, it looks more complicated, right? But I'm forced to teach you this. Yes. Because somebody said try 3. I would have done 2. Does it matter? No. If I take 60 and divide by 2, I'm going to get 30. This is the fundamental theorem of arithmetic. There is only one answer here. There is only one factorization. Okay, what goes into 30? Jack, what would you like to try for 30? 2? Nick? That's 15. Now what prime number goes into 15? 3. There it is. You find the ones that match, that's what comes out. You play the game of concentration. You find the matching cards, you take them out. Right? Remember that game? You never played concentration? Oh, maybe we'll do that on Friday. What isn't it? Jay, are you going to come up and show it? Do it? Jay's going to come up and do it.
Okay, what? So...
Keep on, don't worry. Keep going. Excellent. Okay, did you get that?
No!
Yes. But let's get this one done. Let's try this one. Oh, good. You want to do the next one? Okay, the game of concentration is you find cards that match, or things that match, and you show them all face up. And you try to remember where those matching cards are. Turn them over, and then you just match them. And when they match, you take them away. That one's not easy. That's a big number. Yes. Okay, Joey? No, try 2. Write the 128 down. Okay, we're going to do 128. Janice, what goes into 128?
5.
No, we're going to do it this way.
I'm not sure.
How about 2?
What about 2?
Does 2 divide in?
Yeah.
How many times?
I guess so.
How many times does 2 go to 12?
6.
And 2 into 8 is 4. Okay. So, no. So now you want to divide by what?
2.
2. 2 into 6. You want to write it or you want me to?
3. 2.
Yeah. Keep going.
Right, okay.
Yeah. That's what I do. I just start with that one.
Oh,
Yeah, it does. No, 16. You knew that.
Alright, okay. Then goes 8.
Yep.
Alright, okay.
Yep.
And then it goes 4.
Yep.
And then I do again.
Yep.
Okay, so...
Good. Good girl.
Good shit.
Might be a part. It is a nice. Oh. Yeah, don't do that, Jane. Okay. Okay, ready? Oh, wait. Let me do that.
Oh my god.
There we go. Okay. And what's left? 12. Okay. Now you got to match them up. How many times are you going to take the 2's out? Well, why don't you do them like as a pair? That pair,
I don't like
that pair, that pair. And there's 2 left. How many 2s are here? How many pairs? Yeah,
6. 6 twos, 3 pairs.
3 pairs. So that's 2 times 2 times 2, because there's 3 of them, right?
Yeah.
And the other one didn't have a partner. Sorry, that was going to stay in the radical end. What is that?
6.
I was just going to say it's not 6.
It's 6.
What's 2 times 2?
2 is. Oh, I see 2 pairs. That is 8.
Very good. There you go.
Now.
8 times the square root of 2. Okay. You guys got this? Okay, have a seat. Let's try 50. Oh, we don't have it yet. Let's try the worksheet.
Let's try to work. Oh.
They asked you doing the workshop, going to workshop. No, you didn't divide this. Now you guys put your iPads away. Shall we? Just keep dividing by 2s. Okay, you guys, do the 128. I'll do it again. Hey, girls. You can do it the way you learned before, but this one really works nice. I just can do the answers. Yeah, you're going to have to take it to the media center. I know. Did I give you one, India? I did. Okay, girls. Jane. Girls, go out in the hall until you can be calm.
Can we do our homework out in the hall?
Yes. Do. No, you'll have to plug it in. Okay, you guys, let's look at this again. Okay, let's try this again. They're all gonna split out in home. Okay, what goes into 128? 2. And then how many times does 2 go into 128? 2 into 12 is 6. 2 into 8 is 4. What goes into 64? 1 won't help. Again, what goes into 64? We're doing this again. 8's not prime. 2. 4 is not prime. 2 into 64 is what? 32. Oh, 2 again, doesn't it? How many times does 2 go into 32? 16. Okay, India. 2 into 16 goes 2. 8. Keep going, we're not done. 2. That's 4. And 2 goes in. I have to extend my board here. There. 2 goes into 4 twice. 2 goes in once. Just keep dividing it. Now, if you want to do a factor tree, that's fine, but don't lose factors. Then we count up the ones that match. These match, so that's one of them. These match. These match. If they match, they come out. You get rid of them, and you're still left with that. And this is 8. So let's look at the first one on the pink worksheet, the square root of 50. What's nice about this method is it works every single time. Yes, you can do a factor tree, but I like this. Now, once you learn how to do it, and let me show you the way I do it, I can. What goes to 50? That's not prime. Prime. 5. 5 times what? 5 times what? 10. What goes into 10? 2. What's left? 5. What goes into 5? 5. 5 is 1. Which one's match? The 5. So it's 5 times the square root of 2. Do you want to know how I do it? Because I do it much faster than that. I know the perfect squares. 1, 4, 9, 16, 25, 36, 49. That's usually big enough. We can go one more. 64. And I look at these and I figure out the biggest one that divides into 50. Well, the biggest perfect square that goes into 50 is 25. So it's the same as this. 25 times 2, which is this. Square root of 25 times the square root of 2, and the square root of 25 is 5. There's only, just like in factoring, there's only so many that can be simplified. So I've done them all hundreds of times. So when I look at 50, square root of 50, I can get that. Yes. What repeats? The 5. Oh, you got the idea? If you want to do the factor tree, it's still the same thing. It's 50, and Jack would say that's 5 times 10. Or did you do 25? You did 25. 25 times 2, which now I actually have what I want there, but if I want to go all the way down on the prime factorization, I can. That's 5 times 5 times 2. Don't forget to bring that one down. The ones that match, go outside. Still the same thing. And that's the hardest part here, because I'm not sure you know why. So that's what we're going to be doing this week, and then tomorrow's simplifying radicals is a lot harder than today's.